Hi everybody, I want to start by speaking about the
Empirical rule.
as a demonstration, use some shapes because it's very helpful when thinking about what's happening with a particular shape. One of the most common shapes that we'll see throughout the semester and that we see in the sciences is
the normal distribution,
or the bell curve. So what I'm going to do is place right here an axis, and this is going to represent the x-axis, okay? So what we have here are the values that would occur on the data set. And imagine whatever is perfectly normal goes right in the middle for one variable, right? Then what I'm going to do is put right below that, I'm going to put some z-scores. All right, so this is a z-score of 0, and that means perfectly average. That's a z-score of 1, that's 1 standard deviation above the mean. 2 standard deviations above the mean. 0, perfectly average. -1, that's 1 standard deviation below the mean. -2, that's 2 standard deviations below the mean. What I'm going to do is use some pictures. You've seen these colors before from me. Let's go ahead and put them out here. A lot of arts and crafts times for me. So what I'm going to do is make a normal distribution. Let's think about what percentage of the whole thing is in each shape. Alright, so what I'm going to do first is take these two, like so, like that, and I'm going to put them right there. Alright, that's the green part. This is 34% and this is 34%. So when you add them together you get 68%, and that's the first part of the empirical rule. About 68% of values in a data set or values of a random variable, or we'll be talking about soon enough probability. There's about a 0.68 probability of finding an x value that's between -1 and +1, and that's the z-score. Okay, so next let's add the yellow parts, and the yellow parts each represent 13.5%. Okay, this one takes a little bit of thinking for me to set up. Not a perfect shape here, like no normal curve is ever perfect. Alright, so there we go, and then we'll put this one right here. And now we are on our way to having what looks like a normal curve. Alright, green values are pretty typical. Yellow, not unusual. You got to be more than 2 standard deviations away to be unusual. That's what the red will represent, okay? But in the yellows, a bit uncommon, alright? Now, we have 34%, 34% here, alright? And I'm going to leave these as is right now. And I'm going to add on the last part, which is just the red. There we go. And we have the red, and we have asymptotes with the normal distribution. That just means that this curve extends off to infinity. So we get infinitely close to the x-axis without ever getting there. That's our model, alright? And the same thing with the right side. So take a moment and think about, if we have 100% total, we have 100% of everything that could ever happen, 100% of the money, 100% of the area, from negative infinity all the way out to positive infinity. So just the red plus the yellow plus the green plus the green plus the yellow plus the red, that has to equal 100%, or 1, right? So if this is 34% and this is 34%, think about what the yellow and the red have to be. And this is regardless. If we have a normal distribution, this is going to hold, if we know the mean and the standard deviation, always. These are approximations. Right, what's left over? Well, I took away, from 100%, I took away 34 and 34. There's 32% left over. And if you think about the empirical rule, that's 95% extending from -2 up to +2. That's 95%. So if I take away these two, and that gives me 95%, that's the empirical rule. And then I have 95% total, and I take away these two. Consider what's left for the yellow. This is 13.5%, and this is 13.5%. And that means left over is +2 all the way out to infinity is 2.5%, and -2 all the way out to negative infinity is 2.5%. So what we have is 2.5%, 13.5%, 34%, 34%, 13.5%, 2.5%. So the green is, these are each 34%. Add them together, you get 68%. The yellows, each piece are 13.5%. Notice if you add 13.5 plus 13.5 plus 34 plus 34, you actually get 95%. Usual things that happen in yellow or green. Unusual is more than 2 standard deviations below, more than 2 standard deviations above.